Hello, we're speaking to you today from Australia and Denmark. I'm Shona Goldsmith.
And I'm Ester Garne.
And today we'll be discussing our two partner papers from the Comprehensive Congenital Anomalies and Cerebral Palsy study, which is a collaborative study focused on congenital anomalies in children with pre- or perinatal or postneonatally acquired cerebral palsy.
We'd like to begin by acknowledging this study is a huge team effort, and we are very thankful for the work of all the co-investigators in our study group.
We are interested in congenital anomalies or birth defects because studies have shown that they are a strong risk factor for CP. While studies have reported congenital anomalies in children with CP for many years, advancing research in this field has been hampered by relatively small sample sizes and by differences in study methods, including the definition of included congenital anomalies. To overcome these limitations, new, collaborative, international research is needed. So we initiated this collaborative study between the Australian Cerebral Palsy Register, the Surveillance of Cerebral Palsy in Europe, and EuroCat. We brought together the 9 geographic regions of Europe and Australia that have both a total population CP register and a total population congenital anomaly register. Data linkages were conducted in each region, and then the high quality population-based data from each region were pooled. Our final data set included over 8,600 children with CP.
In our first paper, we included the 8,201 children with pre- or perinatally acquired CP. Using very strict and comparable inclusion and exclusion criteria, we found that 23% of children had a major congenital anomaly. We then looked more closely at these children that had congenital anomalies and used a modified EuroCat classification to classify the children by type and etiology of the anomalies. The largest group of children, 45%, had only cerebral anomalies. Isolated cardiac anomalies were common, and some children had anomalies related to a syndrome. You can find more detail, including the prevalence of each specific congenital anomaly, in the supplementary material of the papers. We then looked at severity of clinical outcomes and found that children with congenital anomalies had significantly more severe impairments than children with CP without congenital anomalies. And this was particularly apparent for children with cerebral anomalies.
Our second paper included the much smaller group of children with postneonatally acquired CP, defined as brain injury after 28 days of life, but by the age of 2 years. Among the 468 children included in this study, a slightly larger proportion, 26%, had a major congenital anomaly, despite acquiring their brain injury later in infancy or in early childhood. In children with postneonatal CP, cardiac anomalies were most common, and more than half of these children had severe cardiac defects. When it came to their clinical profile, severe outcomes were common, but outcomes were generally similar between the children with and without congenital anomalies. Finally, we looked at the causes of brain injury in children with postneonatal CP. We found infection and cerebrovascular accidents were the most common causes. But the causes differed between children with and without congenital anomalies. In those without anomalies, infection and head injury or accident were the predominant causes of CP, while for the children with congenital anomalies, cerebrovascular accidents were the most common cause, accounting for 55% of children.
Because of the known differences in the definitions and coding of congenital anomalies, we recommend CP registers continue to work together to establish a common language for congenital anomalies to facilitate comparison and data pooling in the future. When it comes to the comprehensive CACP study, our next steps are to look more closely at cardiac anomalies and the risk of CP for children with specific anomalies. We are hopeful that by improving our understanding of pathways to CP that include congenital anomalies, more opportunities for prevention may be identified. We want to extend our sincere thanks to our funding support and our collaborators and the staff at the participating Australian and European registers.
Finally, we would like to acknowledge the people and families whose data are included in these registers and make this type of research possible. Thank you for your time.
Thank you.